am going to explain a theorem. A graph is bipartite if and only if it contains no odd cycle. Okay, so here they are talking about bipartite graph and an odd cycle. Right, so here first, before getting into the proof of this theorem, we have to know what is mean by bipartite graph. What is mean by bipartite graph? So here consider there are group of sets in the set X and another group of vertices will be in the set Y. Okay, group of vertices will be in the set X and here is another group of vertices, they are in the set Y. So here in bipartite graph, for every edge one end will be in the set X and another end will be in the set Y. Okay, this is how partition graph look like. Okay, so they are saying that a graph is bipartite if and only if it contains no odd cycles. A bipartition graph should not have odd number of cycles. That is what they are saying. So what is called a cycle? So for example, if I am drawing like this, from V0, V1, V2, V3 and V0. Again I am coming to V0. Okay, so this is a cycle. Why I am saying this as a cycle? Because I start from V0 and I went to V1, V2, V3. Again I reached to V0. So for a cycle, the origin and the terminate point should be same. Then that is called cycle. So they are saying that in a bipartite graph, if you draw the cycle and the cycle's length should not be odd, it will be even. That is what the meaning of this statement. What they are saying, if a graph is bipartite, then it will not have odd number of cycles. Or if there is odd number of cycles, then the graph is what? If there is no odd number of cycles, then the graph is bipartite. Or if a graph is bipartite, then it has no odd number of cycles. That is what the meaning for this statement. Did I told that correct? Okay, I hope that is correct. Okay, now let us move on to the proof. So here, to prove this theorem, first you are considering a graph. So the name of the graph is G. Let G be the given graph. Now, this is if and only if question. So you are assuming the first part and you are going to prove the second part. So first assume the first part. A graph is bipartite. Okay, let X comma bipartite graph know. So there will be two sets. There will be partition, right? So here X and Y be the partition. And also you are considering a cycle because you are going to say the cycle is not even, right? So that if you want to say that, you have to take a cycle first. So let C is equal to, this is the cycle, V0, V1, V2, etc. till Vk. Okay, what's the length of the cycle? Till Vk, and then again it is going to V0. You should say the length of this cycle is what? Even. That is what you are going to prove. That is to prove C contains even number of cycles. So here, without loss of generality, you are assuming, without disturbing any conditions, you are assuming just V0 is the vertex and this V0 is in X. This is what you are assuming. Without loss of generality, we assume V0 belongs to X. Okay, V0 is in X. So then since V0, V1 is an edge of G. Okay, here V0, V1 is an edge. Consider an edge from the bipartition graph, V0, V1. So here consider V0, V1 is an edge of G and G is bipartite. Then it is obvious that V1 will be in the set bipartite graph, no? So V1, vertex V1 will be obviously in which set? Y. So that is what you are writing. Instead of putting since, you can put let. Okay, let V0, V1 is an edge of G and G is bipartite, then it is obviously V0 is in X. Already you assumed, right? So it is obviously V1 will be in Y. That is why, that is what you are writing here. Similarly, if V1 is in Y, then the next vertex V2 will be in the X set. right? So that is what v2 in x, then v3 in y. So proceeding like this, in general what you can say, b twice. So here in the x, have a look at the x terms. X vertexes are in x, they are even numbers, even, right? b in the suffix you are getting even numbers. So in general you can write 2i belongs to x, and the odd vertices are in the set y, right? So that can be written in general like this, b 2i plus 1 belongs to y. Is that okay? Now since so here also, since you are writing this line, how you are writing this from the cycle you have assumed. Here you have a cycle, right? Let's see is equal to v0, v1, v2, etc. vk, v0. So here v0 belongs to x, so vk belongs to y. That is what the meaning, right? Okay. If v0 is in x, means vk will be y. Okay. So that is how from this cycle only you are writing v0 belongs to x, vk belongs to y. Then k is equal to what? K, vk is in y, right? So it will be in odd, right? The suffix will be odd. That is why therefore k is equal to 2i plus 1 for some I. So from this you are writing the length of the cycle C is even. How you are writing that? Is there is any idea? That is, the meaning of this is, if you draw a cycle with odd number of vertices. Okay, that is what the meaning of this. Odd number of vertices. If you draw a cycle using odd number of vertices, you will get even number of cycles. Sorry, the sentence is wrong. If you draw a cycle with odd number of vertices, that you will get the length of the cycle as even. Okay, that is why you are written the length of C is even. Hence G contains, what is the last line? Hence G contains no odd cycle. Okay. Now next to converse part. You have to prove the converse part, right? Conversely, assume what? Assume it contains no odd cycles. What contains? G contains. G contains no odd cycles. That is, graph contains no odd cycles. Okay. It means that is to prove. That is to prove what? That is to prove G contains even cycle. That is what the meaning, right? That is to prove the cycle of G is of even length. Is that okay? Now, to prove, assumption. Oh my god, what a blunder mistake. This is our assumption, right? You are rewriting your assumption. So that is to prove no. That is, you are writing the assumption sentence properly in the next line. In the first line, okay, that is, you are giving more clarity to the assumption sentence that you have written here, right? You are giving more clarity through this line. That is, here you are writing G contains no odd cycles. It means you are assuming G contains even number of cycles. Even, that is, G contains the cycle of length even length. Okay, that is what you are going to, you are assuming. So without loss of generality, you are considering, assume. Okay, let me write that. Without loss of generality, we assume what? G is connected. What you are assuming? G is connected. Usually bipartite graph will be connected, right? Okay, bipartite graph will be connected. Okay, so here without loss of any conditions, you are assuming that our graph is connected. Okay, you are going to prove this graph, connected graph, is bipartite. Is that okay? Okay, so here you are doing something. Okay, here you are considering a vertex. Let u be the vertex and vertex of u be the vertex, arbitrary vertex. That is important. It means any vertex. Okay, any one of the vertex of the graph G. That is the meaning, right? And let capital X equal to, you are considering, okay, capital X equal to like this, capital Y. That is set, right? The partition graph will have two sets. X group of sets, vertices will be in the set X, and the another group of vertices will be the set in Y. So like that, here you are defining a set X, and this set X having elements X. This X belongs to the vertex V such that d of u comma x. What is meant by d of u comma x? Distance between the vertex, arbitrary vertex, and any other vertex from the X set is even. So here take any element from the vertex V such that d of u comma y, okay, distance between arbitrary vertex and any vertex from the set Y, this Y, is odd. This is how you are defining. Okay, also, so from this we can say clearly, what do you get? When you find X intersection Y, you are going to empty, right? There is no common vertices there, right? X is in X vertices are in another area, Y vertices are another area, no common vertices, right? Therefore, when you find the X intersection Y, you are going to empty. What is X union Y? When you find the union, you are going to get all the vertices. So B. Right? Okay. Now we are going to prove XY is a bipartition of G. Okay. To prove XY is a bipartition, that is what we are going to prove. Let me write here to prove. What I am going to prove? XY is a partition of G. Bipartition of G. That is what I am going to prove next. Okay.